Okay guys, here's the second half of our topic 11D through H notes. So we're going to start with 11G, which is the hinge theorem. And I'm just going to start by writing out what the hinge theorem says, and then I will show you a picture as an example. So the hinge theorem says, if two sides in one triangle are congruent to two sides in another, then, notice when we have those theorems, we have a lot of if-then conditional statements. So if two sides in one triangle are congruent to two sides in another, then the triangle with the larger included angle will have the larger third side. Okay, there's a couple of things in here. Oopsie, I spelled triangle wrong there. There's a couple of things that might be a little confusing in this, so let me draw a picture to show you what I mean. So here's my first triangle. Okay, this is going to be A, B, C. Okay, and then I'm going to draw another one over here. I'm going to call this D, E, F. So if you haven't drawn those two triangles, go ahead and do that. And remember, my goal is I need if two sides in one triangle are congruent to two sides in another. So I'm going to say that AB is the same as DE and AC is the same as DF. So I've drawn two triangles where two of their side lengths are the same. Okay? So the first part, my hypothesis has been satisfied. I have two triangles that have two side lengths that are the same. Meaning AB is the same as DE and AC is the same as DF. Because then the triangle with the larger included angle, included just means in between, will have the larger third side. So I'm going to tell you that this angle here is 62 degrees, and I'm going to tell you that this angle here is 37 degrees. This is the included angle between this marked and this marked side. This is the included angle between this marked and this marked side. Because 62 degrees is a larger included angle than 37 degrees, we can state that the length of BC, okay, remember I didn't put that thing on top, the segment mark, so it's talking about the length of BC is going to be greater than the length of EF, and I'm going to write a statement, because AB, segment AB, was congruent to segment DE, AC was congruent to segment DF, and the measure of angle A was greater than the measure of angle D. Okay, so we had two sets of sides that were the same. The included angle here was bigger than the included angle here, so that third side of BC is going to be greater than that third side EF. So that's your conclusion. That would be my justification for why it works. Okay, another way you could justify it was by saying the hinge theorem, but that's why the hinge theorem is working there. Okay, so that's topic 11G. We're going to practice that on a worksheet in a minute. There's one more topic that we need to cover, and that's 11H. And it's the perpendicular bisector theorem and the angle bisector theorem. So let's start with the perpendicular. I'm going to do perp bisector theorem. Okay. Here's the perpendicular bisector theorem. I'm going to leave some room on the side for a picture. It says if a point is on a perpendicular bisector, then, look, there's my if then it is equidistant, that means equal distances, so equidistant from both of the